In this lecture, we'll solve a numerical question. And this is a continuation from my previous lecture, which was titled as PC60. So this is a continuation of my previous lecture, which is titled as PC60. So the same problem was discussed in the earlier one. In this PC60, two non-interacting tanks are operating in series with a steady flow rate of 20 cubic feet per minute. At time t equal to 0, 10 cubic feet of water are quickly added to the first tank. So there are two questions in this. First one is determine the response in the level of both tanks. So this was solved and found out in this PC60. This was solved in PC60. Now we are going to solve this part, second part. We are going to solve this second part. What is the second part? Determine the maximum deviation in level in both tanks from the ultimate steady state values and the time at which each maximum occurs. In the first part, we have found out the level, equation for level. Now we have to find out when will be the maximum deviation in level in both the tanks. Well, so we'll be solving this part 2, second part of this question. And first part was solved in PC60. And the data is given A1, A2, R1, R2, etc. So two tanks figure the usual notations. And what is given here, input is impulse input to the first tank. 10 cubic water quickly added. So input is impulse input to the first tank. So this is the impulse input to the first tank. As a result of this, we have found out what is the level in each tank. So we found out what is H1T and so on. This is for tank 1, which we have found in the previous lecture, PC60. So this H1T, the response of the tank, we found from last class, first part. Okay. Now what is H1T? H1T means what? H1 minus H1S. Now what is asked? The maximum deviation in level in both the tanks from the ultimate steady values. Not just level. Level is found earlier. Now what is asked is the deviation, maximum deviation in level in both tanks from the ultimate steady state values. So that is what is asked. Now this H1T represents deviation in level. This H1 is actual level of the tank. What is H1S? H1S is initial steady state value. But after you give a impulse input, after you give an impulse input as it is in this case, what will be the ultimate steady state level when the disturbances die out? What will be the ultimate steady state level? That will also be equal to H1S. So this H1S will also be equal to the ultimate steady state level. Ultimate value of level. If you want, you can check this in e power minus t. So what will be H1 when t equal to minus infinity? When t equal to infinity, what will be H1 minus H1s here? This equation, H1 minus H1s will be equal to e power minus infinity is 0. So H1 equal to H1s. So the ultimate steady state value when t equal to infinity is same as H1s. Is the same as H1s. So this difference, capital H1T, directly represents the required answer for the question. What is that? So this is the deviation in the level. Deviation, capital H1 is the deviation in the level from its ultimate steady state value. deviation uh, in the level. Deviation in this level is this from the ultimate steady state value. So H1t represents directly the deviation value, deviation value. So when it will be maximum, e power minus t, when it is maximum, when t equal to 0, you can check how does e power minus t curve look. E power minus t, if you plot, it rises suddenly at 0, it rises to maximum value, and then afterwards for any value other than 0, it will be less than 1 only. Ultimately, it becomes the original value. E power minus t becomes 0 ultimately. So this is e power minus t curve. So the maximum value of this deviation, capital H1, occurs at t equal to 0. It occurs at t equal to 0, and its value is, and its maximum value, maximum deviation value is how much? 1 feet. So that is the answer. H1 is maximum. The deviation of the level in the first tank is maximum at t equal to 0. At t equal to 0 here. At t equal to 0 here. And its maximum value is 1. Because if you substitute t equal to 0 here, you get 1. So this is the answer for first part, first tank. Now let's go to the second tank. Now for the second tank, the response in the level of the second tank, capital H2t, in terms of deviation variable. We found this. We had found this from the previous lecture, PC60. Okay. From PC60, from the previous lecture, we found this. So from the previous lecture, PC60, we got this level in the deviation in the level of the second tank. Now, when will this? So again, H2t means same. This H2t means. So this means what? H2 minus H2s. And what will be the ultimate steady state value? At t equal to 0, as I explained earlier, it will be same here also. It will be equal to H2s. Okay, it will be same as H2s. You can check here. You can put t equal to infinity and check. You will get H2 equal to H2s at t equal to infinity. At t equal to infinity. So the ultimate steady state value of the ultimate steady state level will be equal to H2s. So this capital H2 represents the deviation in the level. This is the level of the second tank from its ultimate steady state value. I repeat, this capital H2 is the deviation of the actual level of the second tank from its ultimate steady state value. So when it will be maximum, when it will be maximum, so you have to, this function, when this function will be maximum, what do we find? So you have to differentiate this with respect to t and set it equal to 0 and find out when it will be maximum. So let's differentiate it. So if you differentiate this, if you differentiate this with respect to t, you'll get this dh2 by dt equal to minus 1.4 e power minus e power minus t, and minus of minus plus 1 by 3.5 into e power minus t by 3.5. So set this equal to 0. When dh2 by dt equal to 0, h2 will be maximum. So set this equal to 0 and solve for t. Set this equal to 0 and solve for t. So let us set it equal to 0 and solve for t. What do you get? If we solve this equation for t, what do you get? I will skip the details of solution. The simple equation, you can solve this is a expression in t. If you solve this for t, you are going to get t equal to 1.75 minute. So if you solve this equation for t, you will get t equal to 1.75 minute. So substitute this in H2, you will get H2 max. So what's H2? Where do you substitute this? Substitute this in this. Substitute this in H2, this H2. You'll get maximum H2. So if you substitute H2 equal to, or H2 max equal to minus 1.4 into e power minus 1.75 minus e power minus t by 3.5. So what is this value? So this value is 0.6058 feet. So this is the answer. So this is the maximum deviation of the level in the second tank from its ultimate steady state value is 0.6058 feet, and it occurs at 1.75 minute. So we had found out what is the maximum deviation in the level of both tanks from the ultimate steady state values and what time it occurs. For the second tank, it occurs at 1.75 minute and the maximum deviation is 0.6058. And for first tank, it occurs at t equal to 0 right in the beginning and maximum value is 1 feet. Well, so this problem, both in the last class and this class, explains the dynamics of two non-interacting first order tanks in series. So in the first part, we found out the actual level in each tanks after an impulse input is given. In the second part, we found the deviation, maximum deviation in the level of each tank from their ultimate steady state values. I hope you have understood this. We'll come up with more such problems in the next lectures. Please stand by for more lectures. See you.